All right. Everybody ready? Jaime, Josh, we ready? Yeah? Okay, cool. All right. So talking about even and odd functions here. So first of all, an even function is what we saw on that first page. X squared is an even function because it is symmetric about the y-axis or around. The word about just basically means around. So if you rotate it around a certain, or if you spin it around a certain axis, it's going to look exactly the same no matter what. It'll map back onto itself. An odd function, which is what y cubed is, we didn't talk about that on the front, but an odd function is what happens if it's symmetric about the origin. This is a different type of transformation, but it is a steady transformation. It's what's called a rigid motion. Basically, if you move something but you don't change its shape or size, it's called a rigid motion. And so if you look at this first function here, everybody take a look at the even function up here. Even means, ready, Devin? Even means if you flip it around the y-axis, it maps perfectly onto itself. This point is, well, this is probably a better point here. This point looks like it's about 3 away from the y-axis. This point is also about 3 away from the y-axis. So as long as there's the same distance to the y-axis on either side of the function, that makes it an even function. And then you can see here as well, it says if you take the opposite of the x value, you get, it ends up being the exact same y value, basically what's happening here. The y value is the same because the height's not changing, right? But the x values are opposite, positive, negative, or negative, positive. Over here, this one is symmetric, like the one that we saw in the front. However, it's not symmetric around the y-axis because this point here is 2 away from the y-axis, but it does not have another point on the opposite side. There's nothing there. This one here is a rotation, and it's a rotation around the origin. It says right here, it's symmetric about the origin. So this one does not flip. This one rotates. It's like turning a dial. So if you were to like take this one and then turn it all the way 180 degrees, it would look exactly the same as the original. So you're basically just turning it upside down. So if you turn it upside down, it'll look exactly the same. In fact, if you just turn your paper upside down, it looks exactly the same as the original. So one that is neither means that it doesn't reflect across the y-axis, and it also doesn't look exactly the same if you flip it upside down. That would be neither. And so today we're going to be talking about that. We're going to be talking about transformations as well. And we're going to be talking about recognizing odd, even, or neither based on the function itself as opposed to just the graph. So in terms of our technical definitions here, it says for all values of x in the domain, f of x is equal to the function in terms of the opposite values of x. So basically just flip the x values to their opposites. If it's negative, make it positive. If it's positive, make it negative. This one over here says that if you take the opposite value of x, you also get the opposite value of y. That's what those things mean right there. So basically the x value goes to the opposite and so does the y value. That's what causes that rotation of 180 degrees. And these ones over here mean that neither of them work. And we'll do some actual math examples with them. I know that this is a very technical language in terms of how it's working. The words under here, I think, make a little more sense. If you reflect across the y-axis, you get the same graph. If you rotate it 180 degrees around the middle of the graph, or you flip it upside down, it looks exactly the same as the original. So practically speaking, these are the things that are going to be easy to remember. So this first one here, we already know that this is going to be an odd function because it was the example up top. But this first question says, what happens when you reflect the graph across the y-axis? So if you were to take a point, let's say this point right here, and if you reflect this point across the y-axis, we get a brand new point. This is not on the function. So write this down. You get a point not on the function. As in the back, write this down. If you reflect across the y-axis, you get a point not on the function. If you rotate the graph 180 degrees, you get a point on the function. And I'm going to show you the math in just a second. But we're going to write that down. You get a point on the function. So you get a point on the function. So this first one, you are testing to see if it's even, which means it's not even because you get a point not on the function. The second one, you're testing to see if it's odd. And if it ends up on the function, that means it's odd. So if we test a couple of points here, it says test the points 1, 1, test to confirm. 1, 1 and negative 1, 1 are both on the graph. So with an odd function, I'm going to go back up here real quick. These things are not necessarily the easiest way to describe what's going on. So what I prefer to do is, it's actually something that I just taught a couple weeks ago in geometry. We did a transformations unit in geometry. You did that last year as well in geometry. And so this one basically is saying, if you have an XY pair, go and write this down underneath our definition of an even function. If you have an XY pair, an even function will give you values that are the opposite of X and Y, meaning the only difference between points on an even function are the X values in terms of the reflections. If you reflect points across the X or the Y axis, you will get the opposite values of X, but the Y values will stay exactly the same. So if you have an opposite X and a Y versus your original XY, that means it's even. So if we test that here, here's our point 1, 1. So 1, 1 would have to turn into negative 1, 1, which it didn't. That did not work because that point is here. It's not on the function. So we write not even. You get a point not on the function, which means that this is not an even function. Any questions about that? Basically, it's just like if you have an opposite X value in the same function, that basically means that you're going to end up with an even function as long as the Y values are the same. Now, if we go back up here, let's just write another little rule for this one for odd functions. This right here, f of opposite of X equals opposite f of X. What this means is if you start with an XY value or an XY pair, both of those coordinates are going to end up opposites. So this would be opposite X, opposite Y. So if you have XY values and opposite X, opposite Y values on the same function, that means it's an odd function. So if we go down here and we test the same point, test the point 1, 1, we are now looking for opposite X, opposite Y, which would be negative 1, negative 1, which was true. That one worked. That means odd function. And that's exactly what it says underneath here as well. Test the points to confirm that 1, 1 and negative 1, 1 are both on the graph, and they are. Because if you turn both of them opposite, both of those coordinates are on the same graph, meaning we have an odd function. Any questions about testing points on a function to see if they work? We're going to try another one on the next page. All right. Anybody need more time here before we flip the page over? Get a lot of people shaking their heads. No, we're good. All right. Flip it over. All right. Let's test this one. What is that coordinate right there? 1, 2. Sorry, right there. 1, 2. Okay. This is the point 1, 2. So if we start with a coordinate of 1, 2, if we reflect it across the y-axis, we're going to take the opposite of the x value to keep the y value the same. Is the point negative 1, 2 on that graph? Yes. So is this an even or an odd function? Even. Yeah, even. Good. I'm going to abbreviate function, by the way, as fn. You can just write 2 letters fn, and that's a good way to abbreviate function. That way you don't have to write out the entire word every single time. You know that I love abbreviating things, and this is the mathematical way to abbreviate function. Which means that if it's even, we don't need to test to see if it's odd, because it won't be both. All right. Let's try C real quick. What coordinate are we provided with on C? 1, 2 again. All right. So if we test the point 1, 2, that would then need to turn into what point if it's even? Negative 1, 2. Great. Is the point negative 1, 2 on this graph? No, okay, so not even. All right. If we're going to be testing the point 1, 2 to see if it's an odd function, what would the next point have to be? -1, -2. Good. So if we make them both opposite, is -1, -2? Let's see, 1, 2, 3, 4. So down 4, because those are going by half. There is -1, -2. No, that's not -1, -2. This is -1, -2 right here. Those are each going by half. Is that point on the graph? No. Okay. So it's not odd either. So it's certainly possible for a function to be neither even nor odd. And that's what we see on this. So this answer would be neither. All right. I want you to try A and B down here on your own. There are no test points provided, so you have to go ahead and decide what test point you want to use for these. Oftentimes it'll be obvious what something is not more than what something is. So for example, looking at A, hopefully it's pretty obvious that this is not even. And looking at B, hopefully it's pretty obvious that that is not odd. So I would recommend just test for odd on A and just test for even on B. And if they work, great. If they don't, then it's going to be neither. So give those a try real quick. And let's go with 1 minute. Gosh. Mr. Clark said he needed to see you. He's in the waiting room. I'll just send you down real quick. Let's see if we got it. Okay. All right. So problem number 1, here we go. 1A. Let's see. Abel, what'd you get for A? Didn't do it? All right, let's find out. Take a look. If you go left and right, are you going to get a point if you just go straight across? Like, is it going to be even? No. All right. That means like, no, not a chance. Okay. Give me an obvious point that's on here. Where do you see a coordinate? Negative what? Cool. -2, 4. That's a good point. All right. So -2, 4. What would the coordinate need to be if this is odd? 2, -4. Thanks, Kate. All right. 2, -4. Is 2, -4 on this graph? Yeah. All right. So what is it? Even or odd? Odd. All right. For B, what's the answer for B? Even. Yeah. B is even. Honestly, I think even is probably the easier of the two to recognize because all you have to do is look across the y-axis. If you have points that are the same distance to the y-axis, you're good to go. So like this point here and this point here are each one away. Yeah. So good question. So Rakai just asked a really good question. Basically, you're saying, does the origin have to be part of the graph? It doesn't say that explicitly. However, guys, listen up. This is a good way to tell. Colby. The point 0, 0, because we are rotating it around the origin, 0, 0 probably should be a part of that graph. Now, it doesn't necessarily have to be a part of that graph, but it will likely be a part of that graph. Because we could probably draw something that doesn't end up, like if I were to come down here, and then if we were to draw, let's see, that's a good question. If we were to draw something, that's actually a really good question. I think it does have, because I'm trying to like change it, yeah. Yeah, that's a good point. Yeah, it's basically taking It's basically taking what would be an even function and reflecting it across the x-axis. Yes. So yeah, I would say that 0, 0, again, this isn't something that we're going to write down as like a theorem or anything like that, but it appears to be that if it's an odd function, you have to have the origin as one of your points. So that could be a good indicator. Yeah. All right. This one here, I'm not going to write the coordinates on this one because I think it's obvious that the x values are opposite. So let's flip the page. Now, what happens if we don't have a visual? How could we figure out if we have an even or an odd function if we are not provided with the graph to look at? We could graph it on our calculator if we wanted to, but there's also a way to do it using some algebra. And so what we're going to do is we're going to replace x with the opposite of x. That's what it says right there. Replace x with the opposite of x and then simplify. So let's see what happens when we do that. So basically, we're figuring out, instead of f of x, we're trying to figure out f of the opposite of x. So go ahead and write that down, f of opposite x. And then we're going to write equals. And then over here, we're going to replace x with the opposite of x as well. Make sure that opposite x goes in parentheses to the fourth power plus 5. Ronnie, were you down with state testing? Yeah. Okay. All right. So, real quick. What happens if you take a negative value and you raise it to the power of 4? Okay, it becomes positive. Any negative value, guys in the back, ready? Any negative value raised to an even exponent will give you a positive value. So this is just going to turn into x to the fourth power, positive x to the fourth, because negative raised to the power of 4 gives you a positive number. So this ends up being f of the opposite of x is equal to 4x to the fourth power plus 5. What that means for us is if you take the opposite value of x, you get the same y value. Taking the opposite of x gives you the same y value. What's that? The negative went away because if you take negative x, so here, I'll show you over here on the side. So if we take, if we take negative x to the power of 4 over here, well, just to clear it up for anybody else as well, if you have negative x times negative x times negative x times negative x, because that's what we're saying here, negative x to the power of 4 multiplied by itself 4 times, these two turn into x squared. These two turn into x squared. X squared times x squared is x to the fourth. So they both end up being positive, which means the final result is positive x to the fourth power. And so what we end up with is if you swap out x with opposite of x, the y value here remains the same y value here, meaning what? Even. Yeah. It doesn't necessarily guarantee, if it's an even exponent, it'll guarantee that the exponent becomes a positive value. So like on this next one, we're going to see that we'll end up with some opposite, but there's more than one x on the next one in the y value. So let's see what happens with b. So we're going to replace x with the opposite of x, and we'll see what happens here. So we're going to have g of opposite x is equal to 2 times the opposite of x cubed plus 3 times the opposite of x. So opposite x cubed is negative x cubed. What is negative x cubed times 2? Negative 2x cubed. Good. So this is negative 2x cubed. And then 3 times negative x is negative 3x or minus 3x. Would you agree that we started with 2 positives and now we have 2 negatives over here? Everybody see that? Positive 2x cubed, positive 3x. Now we have negative 2x cubed and negative 3x. So we could factor out a negative from these two, right? if we get rid of a negative out of here, we can say that would be the opposite of, opposite of 2x cubed plus 3x. So g of opposite x is equal to the opposite of the original. So opposite x is equal to opposite y. What does that make this one? Odd. Yeah. So think about this for a second. This is x. This is y. Okay? X here, y here. Opposite x here, y here. So xy to opposite xy means even. Over here, we have x and we have y. And at the end, we have opposite x and opposite y, which means odd. All right, we good? Okay. Yeah. Yeah. Yes. Yes. Settle down. Which one? 2A. Okay, right here.
It seems pretty odd that the origin is that.
So the origin is at 0, 4? Okay, let's find out. So Carlos has a question about 2A. We have to do it anyway, so let's figure it out. So replace x with the opposite of x in everything, and let's see what happens. So we're going to say f of opposite x equals 7 opposite x to the 5th power minus 2, and that'll be opposite x squared plus 4. All right, if your exponent is odd, then your variable is going to be negative. So this will be negative 7x to the 5th power to start things off. If this value is squared, so even exponent means that'll be a positive x squared. So this will still be a minus, and this will just be 2x squared. So we're going to write minus 2x squared. Otherwise, it would have been minus the opposite of x, minus 2 times the opposite of x squared, which would be positive 2x squared, but that turned into a positive, which means that remains negative. And then we're going to write plus 4. So this one, I see what you're saying, Carlos. However, it's not an odd function. It's also not an even function. Here's why. You ready? If we were to remove a negative from all three of these, we would get this. We would get opposite of 7x to the 5th power plus 2x squared minus 4. And if we look inside the parentheses, that's not the same thing as the original value of y. So opposite x produces something that isn't equal to y, and it's also not equal to the opposite of y, which means, what's the answer for this one? Neither. Good. So if this was going to be an odd function, this 4 right here would have to be a minus. All right. Try B on your own. See what you get with that one. Substitute in for opposite x, see what happens. Good question. I know, yeah. Thanks for stopping by. This one should be pretty quick, I hope. What's the answer? It would be, wait, what? X to the 6, it should be the same thing, right? X to the 6 minus 2. So that means it should be even, yeah? The reason why this one has to be even is because if you put an opposite x in for x here, you're gonna just end up with x to the 6th power. So f of opposite x equals opposite x to the 6th power minus 2. That just turns into x to the 6th power. So we have opposite x here, and over here we have what y was originally, making this even. We got neither, and we got even. Cool. How are we doing so far? Isn't too bad, right? Wait till we get to example 3. I'm just kidding. All right. This is the stuff that we've actually already seen before, which is great. So, well, great for some, maybe not so great for others, depending on how you did with transformations the first time. So it says, how do the transformed graphs compare to the parent function? So take a look here. The parent function over here is x to the 4th power. I'll do that one in blue. So x is, yeah. X is this one here. Or F is this one here, rather. So there's F. And I'll get G in red. G of X, we'll put that one in red right here. All right, there's G of X. We got F of X, we got G of X. Okay. Based on stuff that we did a while ago. See if I can find some info in here. Yeah, here we go. So, does anybody still have any nightmares from this stuff? Back from chapter 1 and 2? If you do, I'm sorry, but it's back, okay? So, if you were having trouble with transformations before, here's your chance to learn them again. So, eyes up here. Take a look. All this transformation stuff that we talked about in chapter 1 and 2 is coming back right now. So, my first question for you is, what is different? Please stop talking. Thank you. What is different between how this function is written and how that function is written? Just tell me the differences. There's negative 18. What else? 3. And there's a 3 in front of the x to the 4th. Great. Each of those things means something different. So, if you take a look at the actual graph, take a look at the numbers we have first of all. The scale along the x-axis is going by 1/2. What's the scale for the y-axis? 10, yeah. Scale for the x-axis is 1/2, scale for the y-axis is 10. How much further down is the red one than the blue one? 18. So, minus 18. In fact, this paper here, right here, says, if you subtract something, from the y values outside of the parentheses, that shifts the graph down however far it says. So minus 18 moves the graph down 18. So write this, shift down 18. This is stuff we did back in chapter 1. We're shifting it down 18. What's the other thing you notice about G versus F over here? How is the red one different than the blue one, other than the fact that the red one has been moved down a bit? It's like narrower, right? Yeah, it's getting vertically stretched. And a vertical stretch means that we are multiplying. We're multiplying the y value by a certain number outside the parentheses. So that a value is what's multiplying the x to the 4th on this one. And if that a value is greater than 1, it's a stretch. This should have a little bit more over here. This should say a is between 0 and 1 for the strength, but we don't need to worry about this one right here. We're just focused here. As long as that a value is greater than 1, it's a vertical stretch. This right here, 3 is our a value, which means it's a vertical stretch by a factor of 3. So write that down. Vertical. Hopefully this is review. Vertical stretch by factor of 3. There we go. That's what's happening here. This is just like what we did back in chapters 1 and 2. with transformations. However, now we know whether or not this is an even or an odd or a neither function. Is this even or odd or neither? Even, yeah. And you can actually see that right here, -2, +2, x values are opposite, y values are the same, so they're both even functions. So what we're learning here, by the way, is that if you shift an even function up or down, it remains even. If you stretch or shrink an even function, it remains even. Take a look at the next one. All right, parent function, x cubed. I'll go and highlight that one in blue over here. Here's f, this is our parent function in blue. Hey guys, there's a lot of chatter going on today. Let's go ahead and, all right. Here's our second function, h of x. There we go. So we have a plus after all the parentheses and stuff. What does that mean? What does a +4 at the end mean? Up 4, yeah. Shift up 4, good. It is a vertical shift up 4. We have a 5 outside of the group with our variable. This is just like the last page as well. What does that mean? So the one outside. Stretch, vertical stretch. So vertical stretch by a factor of 5. Now there's one more thing happening. What is it? The -2. It is horizontal, but it's not a shrink. A shrink, horizontal shrink or stretch would happen if the x was being multiplied inside the parentheses. So take a look at this point here, 2, 4, and take a look at where the original middle of the graph was. It's gone what direction? It's gone up 4. We can see that, but it's gone over how far? 2 to the right. Yeah. So shift right 2 or shift 2 right. And if we go back to the little cheat sheet here from chapter 1, the stuff that's happening inside the parentheses, the minus inside the parentheses, you can see right here. If you subtract something inside the parentheses, that's moving the graph to the right, however far h is, and h is 2, so it's right 2. That's exactly what we see here. Now, here's something a little bit different because the original function, the parent function x cubed, is an odd function, right? If you flip it upside down, it's exactly the same. Is this function even, odd, or neither? The one that's transformed. Looks like it might be, but I think it's neither. Because it does look the same upside down, but it's not rotated around the origin. So this one's going to be neither. All right. Let's talk about this one real quick. Somebody give me one of the transformations on number 3. Somebody give me a transformation on number 3 here. Shift down 5. Okay. And what else? Yep, vertical stretch. Factor of 2. Nice. Nice. That's all we got for that. Quick. Any questions about transformations before we continue? This is stuff that, again, this is stuff that's not the easiest to remember how to do, but we've done it a bunch. So hopefully it's starting to get a little bit less difficult than it was. Hopefully. Anybody need more time here before we keep going? I think we'll finish these today. Maybe, we'll see. All right, example 4. So this one, we actually have to identify the transformation from the parent function. So each of the given graphs is a transformation of the parent cubic function or parent quartic function. So cubic function is x cubed, quartic function is x to the 4th power. And it even tells us right here. So it says how can you determine the equation of the graph? So here's what we got to figure out. First of all, how do they look different than the originals or the parent functions? And then specifically, what are the differences? So it says to, first of all, since the ends extend in opposite directions, that means the end behavior shows that the parent function is odd degree x cubed. We start with x cubed, that was our parent function. Now, the parent function goes down on the left and then up on the right. This one is going up on the right and down on the left. What does that indicate? So let's think about this for a second. At the beginning of this chapter, we said if it's up on the left and down on the right, what does that tell us about the lead coefficient? We know it's an x cubed. We know it's an odd function or an odd degree, not an odd function, but an odd degree. Lead coefficient is negative, yeah. So there's a negative lead coefficient, which means it's been reflected across the x-axis. It's been flipped upside down. So there's a reflection across the x-axis. We know that. So let's write that down. Reflection across x-axis. The middle of the graph. The middle of the graph started at the origin. Where is the middle of the graph now? It's what? It's gone left 3 and down 1. Yeah. So shift left 3. And then shift down 1. Now, the reason why there's a couple other points on here, let me just kind of clear this up for you real quick, is if your coefficient is 1, listen carefully. If you have a coefficient of 1, that means that each point from the middle of the graph will be either down 1 over 1 or up 1 over 1. And so because those things still hold, the lead coefficient is still 1. It's just -1 because it got flipped upside down. And so it's been shifted 3 to left, down 1. And so what we're going to be looking at here is we're going to go ahead and use all these 3 things to write the function for that. So we are going to say that f of x is equal to the opposite of, if it's gone 3 to the left inside the parentheses, let's take a look here. If you shift left, that's going to be plus inside the parentheses, however far you went to the left. So in the parentheses is going to be x plus 3. That's the only thing inside the parentheses is x plus 3. Right, Devin? Negative on the outside, x plus 3 on the inside. Keep the same exponent, 3. And if you go down 1, what goes at the end? -1. This is our function. All right. Are there questions about how we came up with that function there? All right, let's try the next one. So again, we're only deciding between x cubed and x to the 4th power. That's what it says here. It says cubic and quartic in the actual problem here. So this one is cubic, this one is quartic. Both ends are going down though. What does that tell us about the lead coefficient? If it's upside down, it's a negative lead coefficient again. So it's a reflection across the x-axis. And then in terms of the middle of the graph, it would have started at 0, 0. It's now at 1, 5. So what are we talking about? Shift. Shift right 5. Okay. What else? Oh, sorry, right 1. Shift right 1. And then what other direction? Up 5. Good. Up 5. Now, because this is down 1 and over 1, even though it's going by halves this time, it's still down 1 over 1, just like this one was down 1 over 1. If it goes down 1 over 1 on both sides from the vertex, that means that the lead coefficient is still 1. So 1 here, 1 here. Which means there's no other transformations that are happening. So we've got f of x is equal to the opposite of what comes next? Do we use parentheses or not on this one? Yes. Okay, what goes inside the parentheses? X minus 1. What's our exponent? 4. And then what comes after? Plus 5. Nice. That's our function for this one here. Yeah, okay. The exponents? This one was just saying the parent function, it says cubic parent function or quartic parent function. So if they're going in opposite, if the ends are going in opposite directions, that's going to be cubic, so it'll be power 3. If they're going the same direction, it'll be 4. Yeah. Otherwise, you would only know if it's an odd degree or an even degree, but it was specific here saying cubic or quartic, so 3 or 4 for the exponent. Yeah. Other questions before we continue? All right, turn the page. We'll do this one, we'll finish up with this one today, and then I'll get you your assignment, and then we will finish this last word problem tomorrow. And then we'll start the review tomorrow as well. So here we go. Determine the equation as it relates to parent cubic or parent quartic. So again, degree of 3 or degree of 4. So first of all, what's the parent function of A? Is that third or fourth for exponent? Three, yeah, because the ends are going in opposite directions, therefore it's an odd degree. And if the parent function, it only gives us 2 options here, cubic, power 3, quartic, power 4. So the parent function here is going to be x cubed, which means that the parent one over here will be x to the 4th. All right, next. Has this one been reflected across the x-axis? Yeah, because if it hadn't been, x cubed, by the way, starts down on the left and goes up on the right. This one is up on the right, down on the left, which means it's been reflected across the x-axis. So, reflection across x-axis. All right, now the middle of the graph used to be at the origin. Now where is it? Yep, it's at 2, 4, so that'll be right 2. And then what else? Up 4. So it reflects across the x-axis. It's been shifted right 2, and it's been shifted up 4. Now the other points around it, are those down 1 and over 1 on opposite sides of the middle? 1, 1, and 1, 1. Looks like it. Okay, so that means that our A value is still 1. It's just negative 1. So somebody give me the equation. What's the function for this one? F of x equals what? Negative parentheses. X minus 2 to the 3rd power plus 2. No, plus 4. Sorry, plus 4. All right. Try B on your own. All right, there it is. How'd we do? This one has not been reflected across the x-axis because it's facing up, just like the original would be. And the vertex went from 0, 0 to -1, -3. So that'd be left 1, down 3. So x plus 1 in parentheses, exponent of 4, and then -3 on the outside. That's our answer for that one. All right. This will be the last one that we do today, down here at the bottom. And then I'll get you your assignment. You can start in on that, and then we'll finish up the last word problem tomorrow. So here we go. Questions here before we continue? So even, odd, neither, and then transformations. So here we go. Apply a transformation of a cubic function. So this literally tells you what you're going to be doing. You've got a cubic function, it's going to be transformed. So the volume of a box in cubic feet is given by the function x cubed. The post office lists permissible shipping volumes in cubic yards. Write a function for the volume in cubic yards if x is the edge length in feet. So let's try to figure out what to do with this. First of all, if you're having trouble visualizing it, you may as well go ahead and just draw a box real quick. And if you've ever struggled with drawing boxes, here's a quick hint for you. Everybody ready? Go just draw a rectangle. Just like that. Here's a rectangle. And then, actually, it says x cubed. So we're actually looking at a cube. So I'm going to say draw a square instead. So let's get rid of that. Let's draw a square instead of a rectangle. We'll get as good of a square as we can. All right, then what we're going to do is we are going to draw another square kind of up and to the right just a little bit. So I'm going to start it right here. So the upper left edge of my second square is going to be here. And what I'm going to do is I'm going to drop a dotted line straight down until I get to about right here, because what I want is the same height on that side of the box as I have right here. And then I'm going to go ahead and draw another dotted line to the left. And I want that line to be about the same length as this one down here. So straight to the left. And that'll put it about here. And I'm going to go ahead and do the same thing all the way around. I'm just going to do dotted lines all the way around for now. And I'll fill some in with solid lines in just a second. But we should basically have two squares-ish. And then I'm going to do a solid line here, diagonally connecting the upper left corners. I'm going to do a solid line here connecting the upper right corners. And I'm going to do a third solid line connecting the lower right corners, like that. And then I'm going to make a dotted line connecting the lower left corners. And then I'm going to fill in the top back one solid, and I'm going to fill in the right one solid as well. And so there's our cube. And the reason why we know it's a cube is because it says the volume is x cubed, which means all the lengths, the widths, and the heights are all the same. Now, x represents what in this particular function? X cubed is the volume, but what does x represent? It says at the very end, x is the in what measurement? Feet. So I'll just say here's x, here's x, here's x. Length, width, and height are all x. Volume is length times width times height. X times x times x is x cubed. That's the volume. And so those represent feet. However, the post office lists permissible shipping volumes in what? Cubic yards. All right. 1 foot is equal to how many yards? What is it? A third. Yeah. A foot is a third of a yard. Everybody cool with that? So x in feet equals a third of a yard. So what we're going to end up with is sub x with, what do you want to call it? About 1/3 x. Because we're talking about yards here. So the volume in yards, each length, well, probably shouldn't say x. Let's go with y. Y for yards. How about that? Sub x with 1/3 y. 1 foot is equal to 1/3 of a yard. X is equal to 1/3 y. So the volume in terms of y, so V of y, is going to equal 1/3 y cubed. Now this volume will be exactly the same as the original volume. It's just going to be in terms of yards as opposed to feet. So what is 1/3 cubed? That's 1/3 times 3. That would be 1/3 times 4. What's 1/3 cubed? 1/3 cubed is 1/3 times 1/3 times 1/3. Let's not use a calculator yet. If you want to use a calculator, that's fine in general. But 1/3 means, V of y means 1/3 times 1/3 times 1/3 times y cubed. So what is 3 times 3? 9. What's 9 times 3? 27. So 1/3 cubed is 1/27. So if you have a box that is 1 foot by 1 foot by 1 foot, 1 cubic foot, that is 1/27th of a cubic yard. So that means, has anybody ever done like bark dust before? Anybody shoveled bark dust before? Yeah, it's measured in cubic yards, right? Usually. Okay. What that means is 1 cubic yard is 27, basically 27 boxes that are 1 foot by 1 foot by 1 foot. That's how much 1 cubic yard is. Like, that's a lot. That's 27 cubic feet. 1 cubic yard is 27 cubic feet. It's a lot. Anybody ever here had a Rubik's Cube before? Where it's like a 3x3 square, right? That's basically what we're dealing with here. That cube that has 1 square split into 3 sections on each side, that would be 27 cubes that make that thing up. So that's how you can imagine one of these is 27 of those. So 1 Rubik's Cube is made up of 27 smaller cubes. So 1 cubic foot, 1 cubic yard is made up of 27 cubic feet. Okay, that's where we're going to stop things today.